Welcome to homework.
Okay, so we have got the following. It's like a alpha beta unsaturated ketone, but also kind of an enol at the same time. The important thing is that we've got to draw three resonance contributors that have, and these resonance contributors have to have full octets, right? So uh, this by itself wouldn't be a valid resonance structure, or this by itself wouldn't be a valid resonance structure because it would leave, a carbocation without a full octet. So we're going to have to involve essentially lone pairs, right? So the first resonance structure we could draw would be to delocalize this lone pair on the OH with this neighboring carbon and move this double bond onto just the carbon itself, right? To give us the following. Positive charge on oxygen and a negative charge on carbon. Okay. And there is a lone pair here, right? Okay. And so the final resonance structure would involve moving this lone pair up onto the oxygen over here. Okay. So these are the lone pairs, the resonance structures that we need to consider. And it's going to inform us where we should put partial charges, on our molecule drawn in the traditional fashion, right? So we really just need to put partial charges that match the formal charges in the resonance structures, right? So this oxygen is partial negative, right? Because there's a resonance structure in which it is formally negative. Similarly, this oxygen is partially positive. And this carbon here is also partially negative. Okay, so that's really what we're trying to do there. So then question 2 is asking, which oxygen in the compound below is more basic? Explain in 15 words fewer and refer to your resonance contributors from question 1, right? Well, what makes something more basic, you know? Right? So it's saying, would this oxygen in its current state or this oxygen in its current state be more attractive to a proton, right? And we need only consider our, uh, you know, partial. We can either refer to the partial charges, or we can refer to the resonance structures. But basically, we're just saying the oxygen A, as they call it, is more basic than oxygen B because, okay, and then the explanation for that is that we have a resonance form in which that oxygen has a formal negative charge, which will make it more attractive to a proton. That's basically it, right? It's also reflected in this, partial charge. This oxygen is more negative than this oxygen, right? So it's more attractive to a proton, which is positively charged.